Okay, so in this we will be knowing about LSA. What is LSA? You remember in hello message I told you they exchange hello packet. Okay, they have
Yes.
different type of messages, but after that we saw something that they exchange LSA, like link state
Yes.
advertisement, right? So what is LSA? Now
Yes.
understand this LSA. Okay, now LSA is known as link state advertisement. The LSA link state advertisements are used by routers running OSPF to exchange topology information between OSPF neighbor. Like if routers wants to exchange, see normally in other routing protocols, router exchange routing table, right?
Yes.
But here in OSPF they exchange LSA, and
Let's
after
see.
receiving LSA, they will build their own routing topology. So
Okay.
an LSA contains routing and topology information that describes a part of an OSPF network. So LSA is what? Link state. Link, you see, normally if you have one router here, okay, if you have one router, so
Yes.
on this router, how many links you have? Four link, right? And all these four
Fox.
link
Yes.
is connected with four different network, right? So
Yes.
this link know about those all networks, right?
Yes.
Yes. That's why it's saying that link information. Link always know about networks. Okay, and link always know the cost of the link. Link always know about the bandwidth of the link. Okay, now router exchange LSA and learn the complete topology of the network. Okay, and they will create identical topology database. Okay, now when two neighbors decide to exchange routes, they send each other all list of all LSA, okay, which is there in the topology database, and after that after receiving LSA, routers build their routing table. Each router then checks
Okay.
its topology database and sends LSA request. Okay, now see what is that. LSA request is there. Request is that if you are missing any topology, like maybe routers first time whenever you will become OSPF neighbor. Okay, so first time router
Okay.
exchange like partial LSA, not full LSA.
Yes.
Okay,
Okay.
yes. Then neighbor router say that okay, now I became your neighbor and I have successfully received your partial update.
Okay.
Okay, so can you please send me full update? Then this is they will send LSA, LSR. Then they will send then again neighbor router will send LSA, the full update LSA. After receiving that, the router will respond with LSU that yes, I have received your LSA, which
Yes.
yeah, which was containing all informations, and then they will become fully, like full,
Never.
yeah, neighbor. Now, how LSA is sharing between OSPF routers? Like, see, here LSA is exchange, LSA is exchange, LSA is exchange. After receiving LSA, this router will build their own link state database, link state database, link state database. Okay,
Okay.
and this LSA exchange will be there in same area. Like if it is area 0, okay, it's not that router 1 is communicating to another router in another area and exchanging LSA. No, LSA is only between the area, and each area will have uh, identical database. Like area 0 will have their own identical database, area 1 will have their own database. Okay, if you want to
Okay.
verify, like if we have this lab here, see area 1, if I'm coming here area 1, routing topology is
Okay.
different, but database is different. So IP OSPF database, see here, database is different. See this router area, like router 1 is connected to which area?
Area one.
Area 1. So he will have only area 1 database, but router 5 is connected to multi area. So if you check here, so
Yes.
IP OSPF database, so he will have this database. See, area 0 database and area 2 database.
Yes.
Okay.
Okay.
And now if you'll check, okay, R2, R1 and R2, they are in the same area, right? No problem. Let's check. You will find same database. Same database. Okay. 212. Here. 212. Sequence number 325. Sequence number 325. Okay. Now, link. What is link? Sometimes people say, what is link? See, link is the interface of the router advertised in OSPF domain. That is link. State is what? Link state. Description of the
Okay.
interface and how it is connected to its neighbor. Description. How it is connected. What is the IP address? What is the cost? What is the bandwidth? Okay. Status is up or down. All this comes under states. Okay. Now, LSA sharing between OSPF routers. LSA sharing between OSPF router is like link state routing protocols operate by sending link state advertisement. That's why OSPF is known as link state routing protocol. It exchange link state. Okay. Now, link state advertisement LSA to all other link state routers. Now, all the routers need to have these link state advertisements so they can build their link state database or
Next step
LSDB.
is
Without LSA, routers cannot build the
the
LSDB.
LS.
Yes. Basically, all the link state advertisements are a piece of puzzle that builds LSDB. Okay.
Okay.
Okay. Now, OSPF routers, LSA flooding. See now. Now you say that we have, understand this. If we have a network with 8 OSPF routers connected on a switch, okay. Now each of those routers, okay, let me, what I can do, let me add one other router also. Just a second. Okay, so you can read the here what is saying that in LSA flooding, saying that in this scenario we have a network with 8 OSPF routers. Let's come here, reduce this. 8 OSPF router, yes, we have 8 OSPF routers here. Connected to a switch, yes, it is connected to a switch. Each of those routers is going to become OSPF neighbors. It, yes, when they are connected here, they will become neighbor, right? Okay,
Yes.
8 neighbors with all other routers sending hello packets. That's okay. Now, and when they will exchange hello packet, okay. Now, now see, this router will send how many hello packet? Okay.
Seven.
No. See here. This router will send one hello packet, right? Okay.
Yes.
Then again, because hello is multicast, so it will send only one, right? Only
Okay.
one, right? One. After that, once the hello is exchanged, now they will start talking as a unicast. So at that time, they will send one, two, three, four, five, six, seven, eight, right?
Yes.
Now, one router, one router will generate, okay, 8 LSA, right? And
Yes.
now you have how many routers? 8 routers.
Eight.
So 8 multiply by 8, 64 LSA,
64.
right? And that 64 LSA will move in that domain, okay. And each router will have how many neighbor? 7 neighbor, right?
Seven.
Right. So that
Yes.
7 multiply by, again they will be exchanging hello and right. So 7
Yes.
multiply by 8, 56, right? So your entire network bandwidth will be utilized by OSPF, right?
Yes.
See, in a simple net, just 8 router and you have this much of bandwidth utilization. LSA is flooding in
Yes.
the network. Okay. So to control this, to control this LSA flooding, OSPF elected as a DR and BDR router in the network. Okay.
Okay, so they can take care of everything.
Yes. Yes. So OSPF DR and BDR routers will take care about the LSA flooding, and they will say that
Okay.
yes, I am boss, please send your update to me, I will be the responsible to exchange with non-DR
Others.
routers, means slave
Mm.
routers. So they will be
Okay.
like king and master and slave. So I'm master, send your
Yes.
database to me, I'm responsible for exchanging it.
Okay.
Okay. Now why OSPF need to elect DR and BDR routers? Now OSPF uses DR designated router and BDR is a backup designated router on each multi-access network. Means Ethernet network, Ethernet, fast Ethernet and Giga Ethernet, not on serial. Okay, we'll do this practical. Okay, see here. If it is serial, see this is the multi-access network. That's why you have LSA flooding. But if it is like this, connect router is connected with point to point, then there is no multiple LSA, right?
Yes.
Okay.
Yes.
Now, so when they are connected to a multi-access networks to control LSA advertisement in a network, they decided to create DR. Now, when multiple OSPF routers are connected to a multi-access medium such as Ethernet or broadcast network, at that time OSPF need to work with DR and BDR concept. A designated router and the backup designated router are elected. Yes, no problem. And we'll see why they are elected. DR designated router reduce network traffic as they maintain the complete OSPF database and then send update to other routers on the shared network segment. Means DR is responsible for collecting all the information and from other routers and they will send to
Yes.
another routers. The other
Okay.
routers become slave to the master. Master is DR and slave is non-DR. Okay. Okay, slave routers only become full
Okay.
neighbors with DR and BDR. Full neighbor with DR and BDR. Okay, and the routers remaining, or
Okay.
you can say remaining routers. Okay, remaining routers will
Okay.
remain at two-way state with other non-DR or non-BDR routers. Means see here, you can elect only two router, one as a DR and one as a BDR, right? So
Yeah. for example, if this is DR, and maybe for this is BDR, okay. So all this will be what? DR other, DR other, DR other, DR other, DR other. Slip.
All these routers will send the database to
Okay.
DR and BDR. Okay. So all this router will have how many neighbors? Full neighbor. Full neighbor is two. One is with DR and one is with BDR. And two-way neighbor
Okay.
is how many? One, two, three, four, five. Five two-way neighbor,
Yeah.
right? And they will
Okay.
exchange database only with DR, BDR and hello only with other routers.
Other
Yes.
slip.
So now see, instead of see each router was initially each router was generating 64 and 64 what you can say 64 hello messages and after that 76 some LSAs, right? But now see now routers are only generating 7 type of messages, 5 hello and 2 update. And now once the update has been exchanged, now only 5 hello. Now DR serves as a collection point of link state advertisement on a multi-access network. A BDR is a
Okay.
backup of DR. If DR will fail, BDR will take over the DR, right? Then
Yes.
another election process will run for
Yeah.
BDR because DR
fail, BDR become DR. So who will become BDR,
Yes.
right? So we'll check that
Yes.
one. Without DR, the information of an adjacency between every attached router would create many unnecessary LSA in the network. That's why we collect DR. Okay. Simply, if people ask in the interview that, okay, what is the benefit of why we should use DR and BDR? So we can say that, sir, to control LSA advertisements in the multi-access network, DR and BDR
Okay.
election is important. Now, mostly students think that this DR BDR election is done per in area. Okay, but I'll show you that if router is connected here. Now see, if we are talking about this interface. Okay, now this lab. Okay, this lab. Okay, now see,
Okay.
uh, here, if I'm coming to R3. Okay, R3. R3 is connected to how many areas?
Two.
Two area. Okay, now R3 will have like how many DR information, because they are connected in a multi-access. How many DR information will be there? Okay, or let me make it simple. R4 is connected to how many area?
Only one.
On only one area. Okay, now tell me how many DR information will be there, because see, here will be one domain, right? Okay,
Yes.
so to control this LSA in this domain, okay, LSA,
Okay.
this router will participate into DR and BDR election process.
Yes.
Okay, so when this router will participate, so this router will become maybe like DR BDR something like that, right? Okay,
Yes.
so this router will become DR BDR, or the link will become DR BDR?
The router.
Router. Okay, no problem, let me show you. So here this router is connected in area 2, so how many DR BDR will be there?
Two.
Only one, you are thinking,
Only
right?
one.
Okay, no
Yes.
problem, let me show you. See here, if I am on router 4, so IP OSPF neighbor. See, you are router 4, right?
Yes.
Router 4 is saying that I have one DR. Okay,
This is 333.
yes, and I have one BDR, right? Okay, now let's
Okay.
come to R3.
Okay.
So IP OSPF neighbor. Now see, can you see how many DR is there? I told you that there.
Three.
I told you that
Yes.
in multi-access network you will have only one DR, right? So you can see here, this R3 is connected to two. This is R2, right?
Yes.
Okay, this is R2. R2 is DR. R1 is DR, right?
Yes.
Okay, R5 is DR. Okay,
Yeah.
and R4 is what? BDR.
BDR.
Okay, R4 is BDR, and R4 is saying that R5 is
BDR.
BDR, and R3 is saying about R4. See here, R3 is saying about R5. Wait. R4
Yes.
is saying, see, R4. Let me explain it. Don't get confused. Maybe let me remove. See here, R4 is saying for me. If you're coming here, R4. For me, R5 is BDR and R3 is DR, right?
Yeah. Yes.
Okay, R5, R4 is saying this guy is DR, okay, and this guy is BDR. Let's verify again. Okay, fine. Okay, and R3 is saying about R5, R5 is DR, Okay, and R4
Okay.
is
BDR.
BDR. So R3 is saying for him is DR, and for R3 is BDR. Now let's come to R5. So IP OSPF neighbor. R3 is what? BDR.
Trace BDR.
R4 is what?
DR.
DR. Now see, R5 is saying
Yes.
you are BD, you are DR. For me, you are DR.
Yes.
Okay, and R5 is saying again for R4 and R3 is BDR. Okay. R3 is BDR. Now understand the confusion. See, OSPF select DR and BDR on a link basic here, not only on a router. See, this link, two link, okay? In this two
Okay.
link, what you will become? You will become DR BDR. So is this link is connected with two routers. So it will say, okay, I am BDR, you are DR, no problem. Okay, what about this link? On this link, I
Okay.
want to become, so here on this link, R3 is connected to R5. R3 is saying to R5, okay, my friend, you are DR, no problem, but I am BDR. Here, see, here, single link.
Okay.
So R3 is DR and R5 is BDR.
BDR.
That's why in OSPF, okay, DR and BDR selection is based on link. Okay, based on
Okay.
link, not on area. Okay. So in a single area, you can have multiple DR, multiple BDR, no problems. Depending on your link, if you have 10 links, your interface will work as a 10 DR, 10 BDR, 10 DR other. Okay.
Okay.
Yes. Now the question will come that how DR and BDR election process will work. Like who will become DR, who will become BDR, who will become DR other. What are the conditions
Okay.
to elect? What is the election condition? So DR and BDR election is determined by router's OSPF priority, which is configured on per interface basis. A router can have multiple interface in multiple multi-access network. Okay. Now, so first thing we have to work on priority. Let's see what is priority. The router with the highest priority will become
DR.
DR, and the second highest will become
BDR.
BDR. If there is a tie between priority, whichever router has the highest router ID will become
BDR.
DR. Okay. Now we'll check this one, no problem. Now default priority on a Cisco routers
Okay.
is link priority is 1.
Okay.
Okay. So link priority is 1. So all router link priority is 1 here. Here, see by default. Okay, this is. Now let me explain you here. Okay. Now here all link priorities one here, one here, one here, one here. Here is also one. Here is also one. So priority is equal, right? Then
Yes.
to compare who will become DR, who will become BDR, who will become DR other, they will check router ID. Okay,
Okay.
RID. Okay. Now, so whoever will have the highest router ID, okay,
Okay.
highest router ID, then that will become DR and second highest will become BDR. Okay, but now if default priority is 1 and I will change to something else because the value I can use are up to 255. If I will make 10, so my router will be always working as a DR if I will change to 10.
Yes.
Okay, and if I will change to 0, then what will happen? 0 means I will surrender myself and say that I do not want to participate into DR and BDR election. I always want to become
A slave.
slave. Now question will come that okay, right now maybe router 1 or someone is DR, for example. Here maybe this one is DR, for example, and you want to make this one as a DR. So if you will change anything in priority or router ID, okay, immediately it will not start new election. Are you understanding?
Okay.
So immediately it
I
will
see.
not start new election. It will wait for that router to go down or interface to go off. Then it will say that my friend, now I am boss. Okay.
Okay.
Now see, let me tell you. Okay. For as of now, this is DR. Okay. And this is BDR,
Okay.
right? And you made this
Yes.
manually to wanted to make DR. So automatically it will not participate, not there will be no re-election, okay?
Yes.
Yes, no or there is no like what you can say, there is no forcefully re-election. So
Okay.
what will happen if this DR will go down? So immediately this BDR will become
DR.
DR and then this DR will become
Slave.
no, my friend. See,
Right?
understand. This DR has gone down. So immediately because this topology know that we have already one
One
BDR.
DR.
So immediately this
Yes.
will become
DR.
DR and this DR will become BDR.
Okay.
Yeah, because see,
For for me, he has to maybe they
no, no,
have
no.
to
See,
do
listen.
a re-election
Yeah,
and
no, re-election is not there. See, this is DR because of election. This is BDR
okay.
because of election.
Okay.
Okay, so if this is down, so this will become DR. Why? Because this guy
Yes.
has already elected as a BDR to become DR,
Okay.
right?
Yes.
And now
This one is
then
successful.
yes, when this will become DR, then there will be a re-election to become what? BDR.
Yeah. Yes.
And this will say my friend, my router priority is higher or my link priority is higher or my router ID is higher, I want to become. So there is already one DR, so this will become BDR.
Okay.
And now if this DR will fail, then this guy will become DR again, like that.
DR.
Or you want to you want to make is forcefully as a DR, then remember that command, I clear IP OSPF process.
Process. Yes.
Yes, you have to run on all the routers. Okay.
Yes.
Now what is DR and BDR selection process? Okay, that was how process works. Okay, this is selection process we are talking. Now
Okay.
first, second, now see, understand. The router with the highest link on the connected, okay, link. Not it's that here I have one interface and this interface priority is 100. So it won't work, okay. The connected one, okay. And if the priority is highest, that will win the election, okay. But by default
Okay.
priority is 1. So we end up with the tie. So in this case, router with the highest router ID will win, okay.
Okay.
Okay, so if we want to change in priority, we can change, okay. Now second condition is
Okay.
saying that the router with the highest router ID is elected as DR and the second is BDR. The router
Okay.
ID can be highest loopback IP, the router ID can be highest interface IP, or we configure router ID, right, like this,
Okay.
okay. Note, the router can be assigned a priority between 0 to 255, okay. But if we make 0, so the link
will prevent becoming DR and BDR, means it will not participate into election. Okay, and remember this one, OSPF does not support automatic re-election. Preemption is what? Re-election. Use clear IP OSPF process command to refresh OSPF database for re-election of your DR and BDR, the new DR and BDR. Okay. Okay. And every
Okay.
time we talk about okay, so let's talk about this OSPF lab. Okay, and then we'll talk about this OSPF network type. Okay.
Okay.
Okay, so let's come to R1. Conf t interface E0 by 0 IP address 192.168.10.2. So we are using this network 192.168.10.0/24 10.1. Okay, 255.255.255.0. No shut, then interface loopback. Okay, not it's not loopback. Okay, interface is completed. Let's do right. Okay, then what I will do here, I'll say router OSPF1. Okay, router ID 1.1.1.1, and then network 0000 255.255 area 0. Let's come here to R2. Conf t interface E0 by 0 IP address 192.168.10.2 no shut, and then router OSPF 2 router ID 2.2.2.2 network area 0. Now come here to R3. Conf t interface E0 by 0 IP address 192.168.10.3 no shut 2 right router OSPF 3 router ID 3.3.3.3 network area 0. Fine. Now let's come here. Conf t interface E0 by 0 IP address 192.168.10.4 no shut
and then router ospf 4 router id 4.4.4.4 network area 0. Okay, now loading done. Now see, understand this. This message will tell you everything. Now if I'm on R1, okay, R1 have received hello message,
Okay.
neighborship, okay, and you can see here full neighborship, right? Full, full, right? So R1 has received full neighborship from how many routers?
Yes.
Three routers, right? R1 has received full neighborship from three routers,
Three.
right?
Yes.
Okay, fine, good. Okay, now come here. R2. R2 also has received full neighborship from three routers, right? R1,
Yes. Yes.
R3 and R4. Okay, now let's come to R3. R3 has received from how many neighbor?
Two.
2. Why not 3? Okay, now R4. R4 also 2.
Yes.
Yes, why? Because that full neighborship will be only
So
with DR and
because
BDR.
they are elected already.
No, 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 no. Elected, yes. So what I told you, the full neighborship will be always with
Yes.
DR and BDR, but other routers, if you are saying here, yes, my
Mm.
so IP OSPF neighbor, you see, I have,
Yes.
see, so they are DR other. Who is DR other? R3 is saying that you are DR other. So for DR
Yes,
other,
they're already there and BDS.
yes. So that's why there is no full neighborship with them. Two-way routers, no full neighborship. Only neighborship adjacency. See here, only adjacency will be
Okay.
only with DR and BDR router. And who are DR and BDR routers? R1 and R2. See here, R1.
Yes.
Okay, R2 is DR. Okay, R2 and this
Okay.
one. Okay. So according to this, R2 is DR and this one.
Two.
Okay. Now, but according to condition, okay, according to condition,
Two BDS.
R4 should
One
become
is BDS.
DR, right? But R4 is DR other. Okay, now see what is the problem and why
Yes.
it is like that. So if I'm coming here on R1, okay, let's come on all the routers and say no router OSPF 1. Let's delete. Come here, conf t and no 2. Come here, no 3. Come here, conf t, no 4. Now if I'm coming on R1, okay,
Okay.
router OSPF 1, router ID 1.1.1.1 and network 0000 area 0 and then exit and then type here so IP OSPF interface E0 by 0. Now see, something is running here. You'll see state is waiting. Which state? DR state is waiting. And see here some timing,
Yes.
wait time for designated router. I'm waiting to negotiate with someone, okay, because see, all will fight
Yes.
for DR, right? Remember, same like root bridge, Okay, all will fight for.
Yes.
So okay, now tell me, do anyone is on this link configured as a ospf router? No. So this router will wait
No.
for 40, see here, wait time. So this is not hello or dead. Okay, wait is
Yes.
same like
Okay.
dead. So if you make dead 80, so wait will become also 80. Okay, and now if you'll
Yes.
wait for wait, okay, I waited and I did not find anyone, so I will become dr. So if you
Yeah.
will configure now as a router 2, router ospf 2 router id 2.2.2.2. So now tell me, this router will also wait for 40 seconds?
Which one? The one that you configured ID?
No, see, this router will not wait because there is already one dr, and this router will not wait. So if we'll check here,
Yes.
so
Yeah.
IP ospf interface is 0 by 0. So this router will not wait, and now this router is what? BDR. Okay, so waiting will
Yeah.
be
Yes.
only to negotiate with other routers. Okay, and now,
Okay.
okay, R3. If R3 is coming now, router OSPF3 router ID 3.3.3.3 network 0000 area 0. No wait, immediately neighborship. But R3 will only make neighborship with two routers. Why two routers? Because see, R4 is blank, nothing is there, and
There
R3
other.
will say, okay, I found R1 as a dr and I found R2 as a bdr. So only two neighbors, because I'm making, so how many friends? Only two friends. Okay, now
Yes.
concept will come on 4 will say router ospf 4 router id 4.4.4.4
Okay.
and then network 0000
Yes.
0000 and then area 0, and then wait. Now only two neighbor. Why not neighborship with 3? Because this R3 was already as a dr other. So for dr other, no full neighborship, because see, you remember hello state, hello init two-way. So you are my two-way friend. No, but these routers dr and bdr routers, they are my full neighbor. And if you'll check here, show IP ospf neighbor.
Yes.
See? You are my two-way neighbor. So two-way neighbor, no
Yes.
database exchange. Database exchange only with dr and bdr. Okay. But now concept will come. I want to make R4 as a dr. Okay. So what you have to do, you have options. Now see, can you see here something like that? Link priority, something like that. See, priority one, like that. So if you want to make R1 as a dr, so you have to come here, interface E0 by 0. Okay, then you type here IP ospf priority question mark. Then you say, okay, I want to make 10. Okay, and then end. And then you have to run one. Remember,
Okay.
clear IP ospf process. Yes, process is done. Now if you are
Okay.
typing here, show IP ospf neighbor.
Process. Yes.
Clear IP ospf process. Okay, you have to run here also, and you have to run here also, on R1 R2 all the routers. Okay, clear IP ospf process. Yes. Okay, then here also clear IP ospf process. Yes. Okay, and now wait, now you see, now if you are coming on R4 to check, show IP ospf neighbor. R4 X start. They are moving now. Okay, now see. R4 is now see. R1 is DR other, R2 is DR other, R3 is BDR. Now it is working as a real exchange, remember? And then R1 is saying that so IP
Yes. F4 is
OSPF neighbor. See? Now who is DR?
F4 is DR.
Yes,
R4, yeah, R4 is
R2 is DR.
DR because of the ID,
Yes,
the high, the highest
yes.
ID.
Now see OSPF. See, we have different type of network. One is broadcast multi-access means
R4.
yeah we have switch connected. Okay, so when we have switch connected, in that case, that network is known as broadcast. So whenever we have broadcast multi-access network, in that we need DR and BDR. Okay, but in point-to-point link, okay, point-to-point link, no DR BDR election. Okay, a point to
Yeah.
multi-point link, which is frame relay, some kind of network.
Yes.
Okay, in that case, no. Okay, configured point to point means configured by administrator like manual neighborship. In that case, no DRBDR. But if we have like frame relay network, we are not using nowadays. So in that case also we used to configure
Okay.
DRBDR. Okay, not configure, it's automatic selection.
BDR and DR.
Yes. Remember I told you about this one. If we run so IP OSPF interface to verify OSPF DR wait timer, and what is OSPF DR wait timer? This question also people ask in interview that okay, what is the DR and BDR waiting timer? Okay,
Yes.
negotiation time.
It's 40 seconds.
40 seconds. Okay. Now see
Okay.
if
Okay.
R1,
40 seconds.
okay, R1 here, R1 is DR for example, and R2 is BDR. Okay, so R1 will make neighborship full neighborship with R3, and R3 will make full neighborship with BDR, but R3 will make two-way with R4.
With BDR and DR.
Yes, and R4 will also make two-way here, but here full and here full.
Wait.
Yes. Okay. Now one more lab here. Like if we are in a OSPF area 0. Okay.
Okay.
Let's make this one for more understanding. Let's work with another lab. I hope IP will be there. OSPF DRBDR
Okay.
lab 2.
Okay. Oh.
R1, R2, R3, 4. Okay, fine. Let's verify. So IP interface brief. Yes, IP is there. Fine. 10.1, 10.2. Fine. Interface brief. Exclude unassigned. So R1 have two interface, two IP. Very good. R2. R2 two interface. Okay, R2 is one interface. See, these are router ID. Don't think that this is a loopback. Okay. So what we can do, we can bring this R1 here. Fine. Okay, no IP on R3. R3. So we'll come here conft interface E0 by 0 IP address 192.168.10.0 255.255.255.0. No shut. Fine, and then save it. One IP also on R1 is okay. R4. Conti interface E0 by 0 IP address 192.168.20.4 0 no shut. Okay, R3 okay fine 10.3 R4 fine and R5. Conft interface E0 by 0 IP address 192.168.20.5 no shut and then okay, let me explain you this lab first. See, R1 is connected with separate LAN 10.0.
Okay.
R1 is connected with separate different LAN 20. Okay, but all are working in area 0,
Yes.
right? So if we are coming here
Yes.
R2, we'll start from R2 conf t. Okay, router ospf 1 and IP address I have already configured like this. See, router 3 10.3, router 2 10.2, router 1 10.1. This side router 1 20.1, 20.4, 20.5. So router ospf 2 router ID we have to assign as a 2.2.2.2
Okay.
or what we can say. Let's come here to R1. Let's configure first R1. Okay, router ospf 1
Yes.
router ID 1.1.1.1 and then network 0000 and then area 0 and then we'll end and then we'll verify. So IP ospf interface E0 by 0. We'll wait for neighborship DR selection. See, state is waiting and wait for 40 seconds. Let's make, we wanted to make this as a DR, that's why we are waiting.
Okay.
21 second, 15 second. This is the wait timer. Okay, 9 7 6 1. Okay, DR. Okay, so this will
Okay.
become DR now. Okay, this is DR. So now come here to here
Yes.
router network 0000 00 area 0. Fine. Okay, so if you type here, so IP ospf neighbor full neighborship. Okay, neighborship is there. Now come to R3
Yes.
router ospf 3 router ID 3.3.3.3 network 0000 area 0 R4 now conf router ospf 4 router ID 4.4.4.4 network fine and then R5 conf router ospf 5 router ID 5.5.5.5 network area 0. Now if you are on R1, see
Okay.
R1 neighborship with 2 3 and 4. Wait for 5.
And four.
Okay, 4 neighborship, right? Okay, you can see
Yes.
here 4 neighborship and R1 is checking here. See, so IP ospf neighbor. See how many DR, how many BDR? 2 BDR, okay, and 2 DR.
Yes.
Okay, means I am DR, that I made it personally as a DR for this link.
Uh,
Okay,
yes.
yes, see, DR for this link
Okay.
and DR for this link. Okay, now tell me, this R2 is connected with how many links? R2, R2,
3. No.
R2, my friend.
2.
Only one.
There's only one here. This
Yes.
one is the switch here.
Okay, this is a switch. So this is what?
Yes.
Now tell me. Here they will negotiate. So this one is, I think, BDR. BDR, because
Yeah.
R2 I configured after that. Okay. So
Yes.
R, here this R3 will become DR other. Let's
Yes.
verify. R1. R1 is saying R3 is DR other, and R2 is, you see, R3 is DR other and
Yes.
R2 is BDR.
BDR.
Yes, and R2, if you'll check here, so IP OSPF neighbor. R1 is saying that R1 is saying that sorry, R3 is saying not sorry, R2 is saying that R1 is DR and R3 is DR other.
BDR.
Okay, because, and if you'll reach, if you want to check real one, so if you'll type CISO IP OSPF neighbor, see, now see, R3 is what? DR other, R1 is DR and R2 is BDR. Okay, same here. Now tell me, this one is what? You configured R4 first, right? So this will become
Yes.
BDR on this segment.
BDR.
Okay,
Yes.
and this one is DR other in this segment, right? No problem. Verify here on R1. R4 is what? BDR, and R5 is what? DR other. And if you'll come to R5
BDR others.
to check here, so IP OSPF neighbor,
Yes.
R1 is DR and R4 is BDR. Okay. So always keep in mind, DR and BDR selection is based on link, okay, or link or segment, you can say. Okay, and tomorrow we will be working on OSPF database type or LSA type. Okay, sometime you can say that OSPF database type or LSA types. Okay.
Okay.